So hey guys, welcome back to another lecture on the system of linear equations. So in our previous lecture we have discussed a lot on the trace of matrices, Harman product and the Norrican product. So today we're going to discuss the system of linear equations. So it's just a big topic, so this lecture is going to be entirely on the linear equations. So what do you mean by a linear equation? So the linear equation is just a equation of the line. It's just a equation of the line. It represents a line, and the equation of this line is a linear equation. Okay, I hope you understand. Like, so we have a h of x and we have a theta 0 and theta 1 x1. So this is the linear equation. So we have a lot of examples over here. So we have a lot of example over here. So we have like a y is equal to 3.5 into 0.5x, or we can write it in a many ways, like we can write it in a many ways, like this. So like 3.5 into a 0.5x, or y is equal to 0.5x into 3.5, or y plus 3.5 is equal to minus 0.5x minus 0.5x, or etc. We can write it in a many ways. Just we take as a random. This is not y0 3.5 y 0.5. I just take it as a random. You may take like 2x plus 2y is equal to 0. So we're going to discuss in just a few minutes. So we have a algebraic manipulations. So this is a algebraic manipulations, like, so we are manipulating these values so to find the another value. I hope you're getting. So I'm going to give a formal definition of this linear equation. So it's just a set of two or more linear equation are working together is called as a system of linear equation. So what do you mean by system of linear equations? Means like a set of two or more linear equations. So what is linear equation? It's just an equation of this line. So you may listening like the equation, but don't worry, I will explain it as much as clear I can. Okay, the set of two or more linear equations, like the two or more linear equations are working together. So they are working together to give a output. They are working together to give a output, and then that process is called as a system of linear equations. I hope you're getting, like, so that is called as a system of linear equation. So as I said, the two are more linear equations. So we can't find a system of linear equations with a one line, sorry, one linear equation. Okay, so I think it makes sense, right? I think it makes sense. Otherwise, just I'll give you example, then it's going to be very easy. Like, so I'll give you a geometric example. Like, so we have a xy plane here. We have a xy plane here. So and we have a line here. We have a linear equation of this, and we have a linear equation of x plus y is equal to 8. So how we find the x plus y is equal to 8, like this line? You might think, right? So you may think like how we find this line. Yes. So like you can research online, like how to plot a line by using the linear equation, or I just simply give a I will just simply give a example. Like, we have a we take the x and values, and we start from -2, -1, 0, 1, 2, and we simply plot. So we just, if we put x value -2, and then what the value is going to be the y. Okay, so if we put the -2 and what's the value of y, so we just simply get a value of y is equal to 10. Okay, so like that. I hope you understand, like that. So if value is -1, then we're going to get 9. If the value is 0, then it is 8. If the value is 1, then it is going to be 7. If the value is 2, then it's going to be like 6. Okay, so we just simply plot this. Like, we have a 2, we have a 4 over there. So in this example, we have a 2 and we have a 7 over there, and we have a 3 and we have a 6 over there, 5 over there, we have 4, and this. So we just simply add the line those points. the points are here, 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 etc. And then we simply plot that point and we get our linear equation line. So same with this, same with this, just practice out or search online. So how to draw lines from a equation, it's just your homework, okay. As I said now, it's just easy, like we take the table. So just research online, you're going to get a brief understanding and you can explore it on your own, like it's just a easy kind of thing. So we plotted the two linear equations. So they are intersecting at a point 3 5, right? So the x is equal to 3 and the y is equal to 5, right? So x is equal to 3 and y is equal to 5, and this is conveying something. It's what is conveying, it doesn't matter, but as of now it doesn't matter, but it's conveying something, right? It's a kind of prediction we use in our linear regression lectures, but it is conveying something. As of now it's just conveying this something, okay, just conveying something to the output, okay. You just think of like this, so it's just conveying something to the output variable, okay. So we have a two kind of dimensions. This is a 2D, right? This is a 2D. If we have a z-axis over here, then it will become a 3D, right? Then it will become a 3D. So we have a xy plane. If x plus y is equal to 6 and this is 2D, and we have a x plus y plus z. So x plus y plus z is equal to 6. We have a z plane over here. So we have a z plane over here. This is 3D, right? This is a 3D dimension. I hope you're getting, like, so it's just a equation of the line. So we can make a conclusions. We can make our conclusions on based on that line. We can have a algebraic manipulations on that linear equation. I hope you're getting. So in our further lectures, you're going to get a good understanding on these linear equations when we start the machine learning. Lectures, we're going to use a lot these linear equations, okay. So after that, there are different types of possible solution cases. So there are three kind of possible solutions, like if the two linear equations are not intersecting, like they are going in a different direction, one is going like this and another going like this, we don't find any kind of a relationship, and so we don't find any intersection over here. So then we simply make a conclusion that it has no solution over here. So then we simply make a conclusion like that, so it has no solution, because they cannot conclude a solution, like they are going same. If it goes like this also, it cannot intersect, okay. It cannot intersect like this. So the no solution is constant. So if you have a linear equation like this, so there is a one intersection over here. So then we can convey like one solution is constant. I hope you understanding, like there's nothing else here. So there is nothing else here, okay. So after that, we have a two lines over here. They're intersecting each other. In a many points or infinite points, okay. This is the third case. So many solutions, more than maybe 1 2 3, maybe infinity also. If the line goes like this, and another line also goes like this only, right? So we have a infinity. So we have a more than one constants, okay. I hope you understanding, like we simply draw a line by using the equation, like plotting by plotting the x values and y values, and we simply form a line, and then we plot it over here. And if we find the intersection, then we can make some kind of conclusions. We can make some kind of conclusions from those points, okay. So I will give a practical example. So I'm going to give a practical example, like how we find the x value and a y value in a 2D dimensionals. So like we have a two equations, right? So we have a two equations. This is our second equation and this is our first equation, right? So from this you can have a y value, right? So we just simply transform the x value from the LHS to the RHS, right? So we just simply transforming the x value from the left hand side to the right hand side, from the left hand side to the right hand side. Okay, so after that we just simply put this y value in our equations, like 3x plus, we simply put the y value like x minus 8, and then we have our equation. So we just simply multiply this 2x minus 2 is just 16 is equal to 19, right? So 3x plus 2x is equal to 5x, and then minus 16 is equal to 19, and then we have a 5x is equal to 19. If it goes to the right hand side, we're going to get 19 plus 16, right? So we're going to get 35 as our this, so we're going to get 35. So if you want the x value, then we have to divide the, it will divide. So if we have a multiplication over here, if it comes to the right hand side, it will divide, so it will divide. So the x value is 7. So if the x value is 7, we're going to simply put in our second equation. What is x plus y is equal to, what is it? It's x plus y is equal to 8, right? So if the x value is 7, then the y is equal to 8 minus 7, and the y is equal to 1. So means like x is equal to 7 and y is equal to 1. So we get our values like x and y. So we just simply calculated these two, and from that, so the process is like, so we have to find some it may be like, so we have to cancel out something, like some constant we have to find, it may be x, like, so I can take also x, like x is equal to 8 minus y, right? So we can take this also, like we can take this also, it makes sense. I think so, like it makes sense, like we can take any value from but so we have to leave the one value to get the another value. I hope you understand, like, yes. So after that, so I'm going to give a 3-dimensional example also. We have a x y z plane also. So we're going to find, so how we going to find how we going to find these values? Okay, so we just simply make it as a, this is our first equation, and we have our second equation, and we have our third equation, right? So we just simply make it our, from this equation, and then we simply plot the y value here, y value in our equation 2, right? So we're going to get like something known as 15 and minus 3x is equal to 5, right? So we want z value. Okay, so we just transfer that, like 5 plus 15 plus 3x, right? Then the z is going to become 20 plus 3x. So we got our two values, like we got our y value and we got our z value. I want to plug these values in the equation 3. So the equation 3 is like 2x plus y plus 3z. So like plus 3z is equal to 15. This is our equation 3. So we have a, so sorry for the dogs out there. So time is 1:30 a.m. So the dogs are barking outside. Maybe they have seen a devil. So yes. So the 2x plus y. So y, what is the y value? 5 minus x, and we have a z value of 20 plus 3x, right? We just simply plug in these values, and we just simply multiply these with the 3, and we're going to get something like this. So we just first we have to identify the x values. Here we have x value, here we have x value. So we just make sure, like, so we just simply bring it all in our first area, and then we simply bring it, so we just transform all these to the left hand side. Okay, so after that 2x minus x is equal to x plus 9x here, and when the 15 minus 5 is equal to 10 minus 60. I hope you're getting, like, so the x plus 10, it is going to 10x, and it will become minus 50. So the x will become minus 50 by 10, and the x value become minus 5. So we have a x value. So we have equation, right? So x plus y is equal to, what is the value, like, so x plus 5 is equal to 5, right? So the if the y is if the x is equal to minus 5 is equal to 5, and then the y value become 5 plus 5, and then y is equal to 10. We get our two values. So we just plug these two values in our this equation, right? So we have a 2 minus 3y is equal to 5. So like z minus 3y is equal to 5, right? So we have a y value 10 is equal to z minus 3 into 10 is equal to 5. So we have a z minus 30 is equal to 5, and then we're going to get z is equal to 5 plus 30 is equal to 35. So these are our final values, like x is equal to minus 5, x is equal to minus 5, and y is equal to 10, y is equal to 10, and z is equal to 35. So we get our values from these equations. So we get our values from this equation. So I will just repeat it again. So like, what is the system of linear equations? So what do you mean by linear equation? So the linear equation is just a equation of the line. It's just a equation of the line. So it's just a equation of the line. So how we find that? So as I said, now how we find the linear equation of the line? So we have a table out there. So just research about it. So the system of linear equation is just a set of two or more linear equations are working together. So they are working together to give a something output. They work together to give a output. So, and we do some algebraic manipulations. So what do you mean by like manipulations? Like, so we are doing, so this process is called as manipulations. So we are doing the algebraic manipulations. Like, so we just put y here in the LHS, and we just transform this x in the RHS. So these are called as algebraic manipulations. And we have plotted a graph here, a beautiful graph here. So you can see this, and how we find these lines from the equation, etc. And we have an intersection over here, and what it will convey to the user. And we have a three kind of possible solution cases, like this is a one case, and we have one intersection over here, and we have a many there. I hope you're getting right. So this here I also given the practical example, like, so how to find the x values and y values, here. So and it's a 2D, and I also given all the 3D. You can find a 4D also, but why to waste so much of time here? So they are beautiful libraries which are doing for us in a fraction of seconds, like as I showed in a NumPy lecture. So it's just doing it in a time of a snap, right? So we going to have advanced libraries there. Just know all of this, because if we code that, so you won't get nothing until and unless you have a good idea about these like calculations, and how these are going to be like. So it's a long lecture, so I'm going to cover these in a next lecture. So I'm going to cover the decomposition of matrices, and we have a Gaussian mixtures in our next lecture. So I hope you enjoyed this lecture. So if yes, then please like and subscribe and share with your friends, because this channel is like a new channel. So share with your friends and your family. So until then, bye bye.